Welcome back. Now we're going to continue talking about the sum and or difference identities um, for different trig functions. And we have three identities that we defined in the previous video. In this video, we're going to do sort of a conceptual problem. So we're given some information, some vague-ish information, we could say, about cosine alpha and cosine beta. And then we're also told which quadrant alpha and beta lie. So we are asked to determine what the exact value of cosine alpha minus beta is. All right, so we don't have a lot to go on here. One thing that's really important for us to recognize would be knowing our cosine sum or cosine difference, in this case, identity. So by definition, and this is an identity we should know, I can take cosine of the difference of two angle measures, alpha minus beta, and I can rewrite that as cosine alpha times cosine beta plus sine alpha times sine beta. So that is my cosine difference identity. If this had been cosine alpha plus beta, then the identity would look the same, but we would have a minus sign in between those two terms. Okay? So for each cosine, sine, and tangent, we have two identities. We have a sum and a difference, and then the sign, when we expand it, can vary. So let's think about solving this. In order to solve this, I need to know cosine alpha and cosine beta, as well as sine alpha and sine beta. Well, I'm given the value of cosine alpha, and I'm given the value of cosine beta, so I know what to plug in for these first two pieces. What I'm not given is sine alpha and sine beta. So what I'm going to do is take this cosine alpha, and I'm going to create a reference triangle. And when I draw this reference triangle, I'm going to note that we are in quadrant 3 between pi and 3 pi over 2. So I'm going to focus on drawing just quadrant 3. When I make my reference triangle, I'm drawing just some angle going down into quadrant 3, and then I drop or raise a vertical to the x-axis always. So we are considering this reference angle here in quadrant 3. Now, cosine is defined as adjacent over hypotenuse. So the adjacent side is 4, and the hypotenuse is 5. But we want to keep in mind the fact that this has a negative in front of it. That means one of these two values needs to be negative. We always let the radius or the hypotenuse be the positive number. And since we are extending left on the x-axis here, that's going to be a negative 4. So now I can easily calculate this vertical side. All I need to use is my Pythagorean theorem. And solving the Pythagorean theorem, I would get the value that my y equals 3. Essentially, I said negative 4 squared plus some y squared equals 5 squared. So I've got 16 plus y squared equals 25, or y squared equals 9. So now there are two values I could square to equal 9, and normally we measure a distance with a positive value. But because we're on the unit circle and we are traveling down into quadrant 3, we're going to refer to this as a negative 3. So now, if I wanted to determine what sine of alpha is, sine of alpha, opposite over hypotenuse, that's going to be negative 3/5. And that should make sense that both sine and cosine are negative, because if we think all students take calculus, tangent Tangent is the only trig function, and cotangent, that is positive in quadrant 3. So sine and cosine should both be negative values. So let's do the same for cosine beta. Now, cosine beta equals negative 2/5, and beta is in quadrant 2, between pi over 2 and pi. So I'm going to draw some angle, and we're going to drop a vertical down to that x-axis. There's my angle beta, the acute angle, always at the center of your reference triangle. So my sides, in this case, my adjacent is going to be -2, and my hypotenuse is 5. Adjacent over hypotenuse. Remember, the radius is always positive, and because this is extending to the left, again, that x value is negative. If we use, again, the Pythagorean theorem, we can calculate this vertical side to be positive root 21. So we said -2 squared, which is 4, plus y squared equals 5 squared, or 25. 25 take away 4, we've got y squared equals 21, or rather y equals root 21. And because we are traveling up, that's why we know this is a positive value. So what is sine of beta? Sine of beta, again, opposite over hypotenuse, that is root 21 over 5. And sine is positive in quadrant 2. So it makes sense that we have a positive output value here. So rewriting my definition, I erased it so I would have more space. Remember, this is cosine alpha times cosine beta plus sine alpha times sine beta. So cosine alpha was given -4/5. Cosine beta was given -2/5. My sine alpha, I calculated that as -3/5. And then my sine beta, I calculated that as root 21 over 5. At this point, I can calculate this value for cosine alpha minus beta. I would have 8 over 25, and then that would be -3 root 21 over 25, combining those two fractions, 8 minus 3 root 21 over 25. And that is my exact value for this difference of angles. So we've got a cosine of the difference of angles. So I hope that helps make sense. Now we're going to talk about, moving forward, some further identities, some double angle and half angle identities.